Now we're going to take a deep dive into a phenomenon known as thermal runaway, which is one of the most dangerous causes of lithium-ion battery failure. Imagine a snowball rolling down a hill, gathering more snow and speed as it goes. That's similar to how thermal runaway works, except instead of snow, we are talking about temperature. Once we exceed a particular temperature for a cell inside a lithium-ion battery, the temperature of that cell will continue to increase at an ever faster rate, like the snowball gathering snow down the hill. This mechanism may continue until a dangerous battery fire occurs. Essentially, thermal runaway is a series of reactions that leads to increasing temperature. That, once started, can be very difficult to stop. Hence, the key to preventing thermal runaway is to never exceed the temperature that starts this thermal runaway process. To understand the thermal runaway process in more detail, let's look at this diagram. Down here is when the battery is operating with cells that are in the safe operating temperature range. Note that this is different to the ambient temperature range and is actually the temperature of the cells. Here the battery is generating some heat, but that is associated with the transfer of charge through the battery and the electrochemical reactions that are needed for charging and discharging the battery. The battery has been designed to handle this amount of heat, and this is completely normal operation. If the temperature of the cells increases to higher temperatures, additional heat is generated due to exothermic or heat-releasing chemical reactions inside the battery. A range of different faults, such as a short circuit, can result in this temperature increase and initiate these exothermic reactions. The increase in temperature during this range can potentially cause damage to critical components inside the battery, so it is not a good thing. However, the battery cooling system can potentially dissipate the heat in this range. However, once we reach a critical temperature, the cooling system can no longer handle the rapid heating of the cell, and the cell enters thermal runaway. Here we can see that the temperature will now increase very quickly. A battery in thermal runaway may catch fire and continue to burn until most of the energy in the battery is used up. Note that the exact temperature for thermal runaway and the safe temperature range will differ depending on many factors. So we can't give an exact temperature value here. But the maximum safe operating temperature for lithium-ion cells is typically around 60 degrees Celsius. Yet again, this varies for different lithium-ion battery units. Thermal runaway typically occurs somewhere between 130 and 200 degrees Celsius for lithium-ion batteries. Be aware, though, that during thermal runaway, the temperature of parts of the battery can skyrocket to temperatures above 500 degrees Celsius. To make matters worse, the high temperatures encountered during thermal runaway cause decomposition and breakdown of internal parts of the battery, potentially causing the production of toxic and flammable gases, and hence an explosion risk, particularly if the battery does not catch fire immediately and these gases are allowed to build up. Inhalation of the toxic gases is very hazardous. So, if you see what looks like smoke coming from a lithium-ion battery, then you need to evacuate the area immediately. This is likely not just smoke, but also the emission of toxic gases, and the battery is likely in thermal runaway or very close to it. So let's talk about some ways thermal runaway can occur in the context of a lithium-ion battery. First, overcharging. When a lithium-ion battery is overcharged, events inside the cell can cause the temperature to rise to a point where the exothermic reactions take hold. This overcharging can be due to a faulty charger or a faulty battery management system, and can potentially lead to thermal runaway. Hence, it is important to use a reputable charger that has been designed specifically for your lithium-ion battery, which likely has protection to avoid overcharging where the charger cuts out before overcharging happens. You can check with the manufacturer about whether the charger has overcharge protection. Next, overheating. Think about a time you left your phone in a hot car, maybe, and it became very hot. That's because batteries can also heat up when exposed to very high ambient temperatures. And this can potentially trigger thermal runaway, particularly if charging and discharging an already hot battery. The battery management system in our phone will prevent us from using the phone or charging it when the battery or the phone overheats. You may have seen that warning come up before. In this situation, you should take your phone out of the hot environment and let it cool down before use and before charging. This protection feature is designed to prevent the overheating from triggering thermal runaway by preventing any further use while the device is hot. The next possible cause of thermal runaway is physical damage. If a battery is punctured or crushed, this can cause a short circuit within the battery. Depending on the resistance of the internal short circuit, a rapid increase in temperature may occur, which can trigger thermal runaway. Hence, it is important never to handle, use, or charge a physically damaged lithium-ion battery. Lastly, we have external short circuits. This happens when the positive and negative terminals of a cell or battery are connected with a bare metal object, like a spanner. A large current can flow through the metal object, leading to a rapid increase in temperature in the battery, which can trigger thermal runaway. All of these conditions that we've discussed can cause a rise in temperature, which can lead to breakdown of the cell's components, further increasing the temperature and potentially leading to a fire or explosion. A real-life example of a battery thermal runaway event is, back in 2013, an entire fleet of aircraft was grounded globally following a series of thermal runaway incidents involving the plane's lithium-ion batteries. One particular instance that stands out occurred in Boston, where the plane's battery caught fire. Upon investigation, it was found that the battery had experienced a thermal runaway event.